So hi techies, welcome back to the channel. As you can see on the screen, today we will be making an intelligent document automation OCR bot. So basically this is a generative AI project. Why generative AI? Because at the end of the day we will be generating JSON file from the images. Don't worry, I will explain you all the things from the scratch. So suppose in your organization, I will first give you the problem statement. So basically, organization receive thousands of document images such as receipts, invoices, bills and forms every day. Manually reading these documents and entering the information into a database is time consuming, costly and error prone. The goal of this project is to automate this project by extracting text from document images using OCR and convert it into structured information using Gemini AI, reducing manual effort and improving efficiency. So basically this is an generative AI project, and this is the first generative AI project which we are doing in this channel. So basically I am again and again repeating a word OCR. So let us first understand what is the full form of OCR and what it is. So basically OCR stands for optical character recognition. Let me write it. Optical character recognition. So now you would have understand that what will be in layman language we will be doing in this project. We will be having some images. From that images we will be extracting the text, and from that text we will be converting them into JSON format using Gemini API. Simple it is. It is having the pipeline I will be showing. It is not very big. We are not doing training testing over here, so it would be a very short and beginner friendly generative AI project. You can add this project in your resume. As a beginner in generative AI, you can understand this project very well, and I will make it very easy for you to understand. First we will covering the theory, then only I will be writing the code so that you can understand the code very easily. So let us understand. So what does optical character recognition do? Basically, it converts text inside an images into machine readable text. OCR does not understand the meaning. It only recognizes character. So as we know that machine does not understand an image. It understands numbers and all that. So what this OCR will do? It will convert all this images into text format so that machine could understand it. But don't confuse that OCR understand the meaning of text. It just converts the image what is written inside image into text. So if there is image and text inside it, it will just convert that image text into text, but it will not understand what is written inside that text. We will be using another term in that, which is IDP. Intelligent document processing, and yes, it is our next topic, IDP. The full form of IDP is intelligent document processing. So basically you can understand in this way. You can understand in this way that suppose OCR is saying, see, here is all the text I found. Then what would IDP do? IDP say, I know which text is the invoice number, which is the date, which is the total amount, and which is the vendor. So basically, if you say, IDP will say, it will like recognize the text. So basically, we will be using the images of bills, which will be having invoice number, date, amount. So basically IDP will be recognizing all these things. We will discuss about data sets in a while. Until then, let us see the difference between OCR and IDP. Basically, it read the text, it understand the text. Okay, plain text output, it have structured data. No context, it uses context. Okay, so these are the basically three difference I am remembering. You can just, if you want, you can Google it more, you can get more. So now I have told that. So I will now tell you the pipeline of this project, which is very important thing. And if you don't pipeline, yeah, I will use it. Pipeline. First, we have receipt image. Next, we will do image pre-processing using a Python library known as OpenCV. We will be discussing about it later. And in-depth OCR, Tesseract. Okay. Next, we will get our raw extracted text. So from here till here, from the images, we have extracted text. Okay. Next, we will be using Gemini API. What will Gemini API do? It will convert the extracted text into structured JSON. And we will save and display result. Okay, now you can ask a question, where does Gemini fit in this pipeline? Basically, what does Gemini do? Gemini adds understanding and structure to the OCR output. Gemini adds understanding and structure to the OCR output. How? Let me explain you this. Suppose OCR has produces a text ABC. We are taking an example of a receipt. So we are getting ABC store. Okay. Dividing into 2. Total is 560. GST is 28. Date is 12/06/2026. So what does basically Gemini transform it into JSON format? Why JSON format only? Because most of the model which we train, we use JSON format. I and my company also use JSON format to train our model. So it becomes easy. So JSON format looks something like this. Store name, store underscore name. What was our store name? ABC store. Okay. Date, semicolon. What was our date? Next is our total, which is 560, comma. Next is our GST, which is 28. So basically, what is Gemini doing? Gemini is converting this text, all this text, into structured JSON format. Okay. So if you talk about most time consuming step in this project will be image pre-processing. Next are small like phases we will be do, but the whole project is very interesting and trust me, we will enjoy it a lot. Okay. Now let us talk about the tech stack. I will tell you what other tech stack we will be using. Python programming language. See, these are the prerequisites. I won't be teaching Python in this project. So you must have known the basics of Python. Rest, leave it to me. Okay. Google Colab for environment development environment. Why Google Colab? We should have using Jupyter Notebook or VS Code, because I think like Google Colabs give you like bigger space and it has GPU and also, so make it a practice of using Google Colab as compared to Jupyter Notebook and VS Code. Okay. OpenCV. This is an Python library basically used in image and video pre-processing, also like reading the images and understanding the video. We use this library. So image pre-processing. NumPy. NumPy will play a very important role in this project. It will basically help in image array. Pillow. PIL. We will be using in image handling. Image handling. Next, Tesseract OCR. We will be using in text extraction. Okay. We will be using Tesseract also over here, which is Python wrapper for Tesseract. Python wrapper. Next, Gemini API. Information extraction. Information extraction. Last but not the least, Matplotlib. For image visualization. Image visualization. So now I will be all that I have taught you till now, I will be asking you some interview questions so that you can also become interview ready simultaneously. By seeing this video, you are also an interviewer ready. Don't worry, I will be asking only the question which I have taught till now. First, what problem does this project solve? think in your own words. One hint I can give you, that this was the first thing we discussed. This is basically somewhat a problem statement. Now, what I want you is pause this video, take a while, frame the answer in your mind, and then I will tell you the answer. So basically, when we have to extract text and understand the meaning of the text from images, we can use this project. Simple. Or you can refer to the problem statement. Okay. Second. Okay, I will give you a better answer than this also. Basically, this project automates the so if you give to answer to an interviewer, this I tell you in simple words, but if I have to answer to an interviewer, you can say that this project automates the extraction of information from document images such as receipts, invoices, bills and forms. Instead of manually reading thousands of documents, the system uses OCR to extract text, and an LLM which we are using over here is Gemini, to understand the text and convert it into structured data like JSON. Got it? Now next. What is OCR? Think about it, about the full form and all that, then we will discuss. So as I have told you earlier, OCR stands for Optical Character Recognition. It is a technology that converts text present inside an image into machine readable text. I have told you earlier, if you might have remembered, you must have answered it. Third, difference between OCR and IDP. Think about it. So in simple words, if I say OCR only extract text, but IDP understand the meaning of the text. Perfect. Fourth, why can't OCR alone solve the problem? See, if you don't understand the text, it is of no use. Now try to frame an answer. Okay, I will tell you. OCR only extract text but cannot identify what each piece of text represents. For example, it cannot determine which value is the invoice, number, date or total amount. Additional intelligence is required to interpret the extracted text. Next, why Gemini? This is the last question here, but so basically, if in layman word, if I say Gemini helps in converting the text into JSON format, but from the interview point of view, a good definition would be Gemini understands the context of the extracted text and converts unstructured OCR output into structured JSON containing meaningful fields like invoice number, date, vendor name, total amount and GST. Okay, so if I see, I will ask you write the pipeline over here again. And pipeline is something, it should be in your mind. So pipeline is image pre-processing. These are the steps you must remember in this project. OCR, raw, extracted, text, Gemini, structured JSON, result. So these are the steps which we will be focusing on. Next, we will be understanding See, I think it's been a while, but we haven't write a single piece of code. Why? Because what I want is to first you understand what we are doing, what is our objective, what are the things. I could have like in the first place only opened the Google Colab and wrote all the code, but I want to give more time on explaining you things how the things will work. So writing the code will become easy for you. Okay, now we will be understanding the digital images. So what is happening all? Basically, for an image, computer just sees number, nothing else. Okay. So if this is an image of a boy, we can see a boy is here, but the computer will only see numbers 1, 2 and all that for that. So let us start with what is an pixel. You must have heard that this camera is 48 megapixel, this is of 100 megapixel and all that. So what is an pixel? Pixel is the smallest unit of an image. I will give you example. You must have played Legos in childhood, small blocks. They are like put together and we build a wall, something like that. Okay, you understand that each Lego is itself it is very tiny, but together you see it is has created a wall. Similarly, thousands of blocks together create a picture. So basically, when thousands and millions of pixels wind up together, they form an image. Okay, so you can understand that every square over here is an pixel and the whole wall is an image. This is the simplest explanation I can give it to you. Now, come to image resolution. What is an image resolution? Suppose an image is 100 into 100. That means there are 100 rows into 100 columns. Okay, which will be equal to 10,000 pixels. Simple, no rocket science over here. Now, if I say we have of 1000 into 1000, it can, so it will become, so much pixels is possible. Yes, it can be 1000, it can be millions. Big images can contain many pixels. So it's not a big deal. But one advantage of having more pixel, can you guess what? More detail, high resolution image you will get with more pixel. It's a very good thing if you are having more pixel. Okay. Now, coming to pixel values. Suppose the image is black and white. Each pixel has only one number. 0 means black, 255 means white, and 128 means gray. So an image matrix would be something like this. 0, 0, 0, 255, 255, 120, 90, 80, 70, and 50, 30, 255. It is nothing. It is, you will just realize it is a NumPy array. That's why I was saying NumPy will play an important role. Okay. So an image is an image is converted into an NumPy array. Now, grayscale. What is an grayscale? I will tell you. And why do we convert an image into a grayscale? So basically, our receipt don't have color, but basically image has color. Three colors are there. So basically, what does grayscale do? Three color are there: red, blue, and green. Mostly all the color are combined. So basically, grayscale, what does it do? It converts all the color into a single channel, which is one channel. So it becomes easy for machine to learn it. Basically, OCR cares about the shapes of the character, not whether the text is red, blue, or green. Okay. So does that color help, all these three color help the OCR to read text? No. So we convert our RGB image into grayscale, one channel instead of three. One channel instead of three. Faster processing, less memory. Better OCR, better OCR. Okay, so this is basically grayscaling. If I show you the receipt, there are basically no colors over there. So here we won't be like it is of much use, but it is a general practice to convert an image into a grayscale. Okay. Now we will start doing with the coding part. And in between, I will be explaining you each part of the code. So don't think that it is like finished, like I won't be explaining. But for now, let's do the coding. So this is your Google Colab. You have to just go to Google, type Google Colab on your Chrome. First link which will be there, go there, click on new file, you will be seeing this file. Okay. Now the data set which we are using is this one. I will be, see the image is something like this. Okay. So I will be sharing the link of the data set. So don't worry about that. I will be sharing many links like this. I will be sharing this document link with you. I will be sharing the after download GitHub link with you. I will be sharing that data set with link with you. So all the links I will be sharing, you don't have to worry about that. First thing is importing libraries. Import CV2. What is CV2? Yeah, this is the OpenCV, which will help us to read the image, like read the receipt, all that. So where we use that CV2 or OpenCV. Import NumPy as NP. Why NumPy? I have told that the image which will be getting will be after that pre-processing, it will be in NumPy array format. That's why we are using NumPy. Import matplotlib.pyplot as PLT. Basically, we will be using for it as data visualization. Next, if you want to see the versions, you can just write this piece of code. You can see your versions. Okay. So OpenCV version I have this, and NumPy version I have this. This is which is completely fine. Now, data set. Okay. For data set, you have to just go over on this link which you can see, download it, just copy this, and you can just copy it from here, you can paste it over here. Now explore. We have got the data set. Now we will be exploring the. For that, we will be writing this. Now, a very interesting thing you will see. We have test, we have test entities, we have test images, we have text box, which is text format. These two are text. This is only in image format. Again, we have train entities, train images, and train box. Only train images is in image form, and we will be using this test images. I think so. We are having this folder. Let me explain. Let me explain you. I think it would be becoming difficult for you to understand. We have a folder name SOE 2019. Inside that we have two folders, test and train. Inside that test we have three folders. First, entities, which is in text format. Next, images, which is in PNG format, JPG format, and again we have box, which is in text format. In train also, all these three are same. Entities in text format, image in JPG format, and box in text format. Now, out of all this 6, what we will be using? We will be using this. Why? Because this contains the images. These are the, basically they have extracted the text from these images and saved over here, but we have to do this project from start. We have to first understand the images, we will be do grayscaling and all that, then we will be extracting the text. So we will be using this. You must have coming into a mind that why not this here also, but this is of train and this is of test. This is having more data. We are not training over here. In the pipeline, have you seen I've written we will be training our model and testing it. Then why would I be using train? Yes, I will be using directly test. Inside that I will be using images. Nothing else we will be using in this data set. Okay. So again, an interview question. See, I am trying to take maximum interview questions so that along with writing the code and understanding this project, you are also interviewer ready. Okay. If the interviewer asks, why did you use the test images instead of the train images? You can give a strong answer. Since I was not training an OCR model but building an inference pipeline using pre-trained components like Tesseract and Gemini, I choose the test images to stimulate real-world unseen documents. This better reflects how the system would operate in production. Okay. Next, we will be counting the images. How to count the images? Let us write. Okay, so there are 973. Okay, so I have taken 3 extension over here so that no image is left. But if you will have time and go and check the data set, it only contains JPG images. Okay, and 973 is a big number data, so that's why this data set is very popular in whenever we do OCR projects, right? Now we will find one images so that things become easy for us and we can actually see on what type of images we will be working. Finding one sample images. Oh, sorry. Okay, so we have chosen this and now we will be reading an image using OpenCV. So let's continue and I would be writing over here reading and image using OpenCV and I will highlight it. Yeah. For that step would be importing step 1 is import OpenCV and I think by now you have got it how to import. Just import CV2. Next step. Next, if our interviewer asks you what is OpenCV, you can just answer it OpenCV, Open Source Computer Vision Library. Let me write it down for you. OpenCV full form is Open Source Computer Vision Library. Okay, so basically it is an open source library used for image processing, computer vision and video analysis. Image processing, computer vision and video analysis. Okay, it provides function for reading, manipulating, analyzing and processing image and videos. Okay, so this was OpenCV. Next, let us move forward. Let us read an image. Step 2 is we have written, see over here the path of the image is image path. We have taken image, so we have saved that in image path. So how to read? Let's store in image variable cv2 dot I read, I am read, yeah, I am read and image path, image underscore path. Let us run it. Yeah. So basically cv2.imageRead does not return a picture. Don't get confused over here that it is returning an images. What is it is returning? It is returning an numpy array as I have told you. Okay. So let me tell you the internal working, what is it is doing. So basically it is, we have the receipt dot jpg What does it do? It is reading every pixel. Next, convert every pixel into number. Then store those number inside a numpy array. And return the array. And how can you check that it is returning the array? Next step, I will do that. By the use of data type, which data type it is returning, we can check that. So step 3 is check the data type. Simple. What I would write it here, I will be printing the type of what? Image, which I have created in the previous code. Yeah, numpy array. It is returning a numpy array. Okay. So basically, why it is a numpy array? You must have getting it is converting into numpy array. So why numpy array? I will be explaining you that also. See, every code why I am using, I will be explaining in this project. It is an end-to-end project. Everything I will be explaining. If you understand it, then only you use this project. Okay, but you will be understanding very easily and very. So basically, what does computer understand? It understand numbers, arrays, and matrices. What does computer doesn't understand? Receipts, which is our data set only. It does not understand. Images. It does not understand. Not even words it understand. So basically, what is OpenCV doing? It is converting image into numerical value. Image into numerical value with the help of OpenCV. Okay, so this is the thing. Now I will be checking the shape of the image. So what code I will be writing? This is a step 4. Check the shape. For that, I would be just be writing print image dot shape. Okay. Next, I would be checking the data type of the pixel. For that, I would be writing print image dot d type u int 8. Now what it is, I will make you understand. So what we have got, the data type of pixel uint8. Here u is unassigned. See, we are breaking it into 3 parts. uint8 unassigned, int integer, and 8 what means 8 bits. Okay, so an 8-bit unassigned integer can store value from 0 to 255. Now think back to grayscale images. Remember, black was 0 and white was 255. That's why OpenCV store pixel value as uint8. Okay. Now we will count the total number of pixels, which will be our step 6. For that, okay, so this much size is there and it's no need to worry. We always get large size. So I am asking you a question. What do you think image.size means? Hint. If image.shape is 100 comma 200 comma 3, then the size would become okay, I will be writing. Suppose image shape is 100 comma 200 comma 3. What does its size becomes? It would be 100 into 200 into 3, which means 60000. See, it's very 60,000 pixel it is becoming. Okay, so that I want to say that total number of pixel, how does we calculate? Next, number of dimensions, which would be our step 7 is number of dimension. Print the image dot n dimension. 3 dimension. 5, because a color has height, width, channels, so we are getting 3 dimension. Next, I would be printing some of the values and see what I will be asking. Okay, now see that, and I will be explaining each of them what I have done over here. Okay, so let's start. First, I have written type of images and we are getting numpy d array. What does it mean? Basically, for the first one, basically confirms that OpenCV does not load a picture as I've told you earlier. It loaded a numpy array. Think of this like that. We have receipt, then we do cv2.imread, then numpy array, and then we have blue, green, red, this, comma, blue, green, red, this, and so on. So every image operation, grayscale, blur, thresholding, is simply modifying this array. We are working on this array now. Okay, so that I am saying that numpy array, what does it mean? Next, we got our some pixels we got. Okay, so in which image dot shape we got some pixel. Now we will be understanding what is happening over there. And this is basically one of the most important OpenCV property. So our receipt has height of 1695. From that number we can get that width of 932 pixels. These are all pixels. Okay, and channels are 3. What are they? Blue, green, red. Okay, so why the shape is 695 comma 932 comma 3 and not 932 comma 1695 comma 3? Because NumPy stores array as rows comma columns, which means height comma width, not the other way around. Many beginners get this wrong. Okay, so we always take a shape as this we take, and not, okay, we never take that. I explained you why. We are getting image.dtype as uint8. I've explained you that. So basically you can, if you imagine one pixel be 15 comma 120 comma 255, this means blue is 15, green is 120, and red is 255. Okay, notice the order. It is blue, green, red, and not red, green, blue. Okay, so this is specific to OpenCV. Fourth, we are saying image dot size is something a number 473. Many students memorize this. I want you to derive it. Your shape is 1695 in like right now it is 932 comma 3. Okay, multiply it. Just simply multiply it. 3. It would be, so first 1695 into 932 is 1579740 pixel. I've used a calculator. Don't understand. I'm so good in maths. Next 1695 into 932 into 3, which is 4739220 values. Okay, so it's not a rocket science which you are getting. So basically this is not the number of pixel. It is the total number of stored value. Since each pixel has 3 values, blue, green, red, the total values are pixel into channel. Okay, because the color has 3 dimension. Dimension 1 is height, dimension 2 is width, and dimension 3 is color channel. That's why it is called a 3D array. Okay. Now we will be using displaying the images. Now we will be step 1, display the image. So to display the image, we will be using matplotlib, and I would be writing import matplotlib.pyplot as plt. Next, plt.figure fixed size is 8 comma 10, and plt dot imshow, which is image. Okay, plt dot axis is off, and next plt dot title I am keeping over here is receipt image, and plt dot show. Now you can see that our receipt how it is. Okay, so these are the values that we have to extract, tax, invoice, and all that we have to extract from this. Now we will be converting our blue, green, red into red, green, blue. Okay. How? With just this piece of code, you can convert that. So what is cv2.cvt color over here? So this is the most frequently used OpenCV function. Here source image, the image you want to convert, image conversion type is what conversion you want. So we are saying that take the OpenCV image stored in BGR format and convert it into RGB format. Okay. Now I will show you the converted image. So for that, sorry guys. See, you can't see so much change because we are not using color over here, but that is a good practice. Now we will be doing the pre-processing, and for that I would be writing a simple piece of code. So you can see the shape is 1695, 932 and u int 8. Okay. So why is grayscale used before OCR? You can say that OCR focuses on recognizing the shapes of character rather than their colors. Converting an image into grayscale removes unnecessary color information, reducing the image to a single channel, lowers computational complexity and simplifies processing techniques such as thresholding and noise removal. Now comes to thresholding. Thresholding. So for that, I would be writing this and see. Now you can see before the image, you can compare that the image has become much clearer right now because of thresholding. Okay. So what does thresholding do? Thresholding chooses one threshold value. Suppose the threshold is 128. Then OpenCV asks every pixel, are you greater than 128? If it say yes, make it white. If no, then make it black. So clear cut things. That's why our thresholding becomes good. Now for binary image, I will be writing this. And why binary image? Because there are two values, white and black. That's why binary we are seeing. Okay. And next is our Tesseract. I will explain you what is Tesseract it again. Okay. Tesseract. Tesseract is an open source OCR. OCR was optical character recognition engine that converts text present into an image into machine learning text. So here only our text will be converted into machine readable text. You can it is not just a Python library, it is like a engine type of thing. Okay, so we will be step one will be installing the Tesseract. So I would be writing step 1 over here, install Tesseract engine. For that I would be writing in Google Colab it is different, so Google Colab. Okay, apt get update. Next is apt get install Tesseract OCR. Now it is installing and it's a very good thing. Now I will be installing. Step 2 would be install the Python wrapper. For that I would be pip install Tesseract, and I would be installing that. Next step would be, step 3 would be importing the Tesseract. Step 3 is importing Tesseract. For import, we have to just import it. Import and next we will be checking the step 4 is checking the version of it. Check the Tesseract version. For that, I would be writing, basically printing Tesseract dot get underscore Tesseract underscore version. Okay, and I would be now be extracting the text from the original image. So what code I can write? Text is equal to dot image underscore to underscore string of image print of text. I hope I've written, yeah, it is right. Okay, so we have extracted the text from the image now. Then compare original versus grayscale. I would be comparing. Step 6 is compare original versus grayscale. For that, I would be writing text underscore gray is equal to pi Tesseract dot image to string of gray, and I would be writing print text gray. Just the difference between the previous code and here is the text is of gray. Okay, nothing else. And I would now be comparing the threshold images. I would be, step 7 is compare the threshold images. How I would be doing it? Text underscore binary is equal to pi Tesseract of image of binary, and I would be writing print of okay. So I have compared the threshold images. Now you have three OCR outputs: original image, grayscale image, and threshold image. We will compare them to see which pre-processing give the best accuracy. Okay. So for that, I would be writing this, and so overall accuracy, if I want to say that, I would say that is 97 to 98 accurate, and that is actually very good. So if the interviewer asks you, how does OCR always give 100% accurate result? No, simply say no. OCR actually depends on the image quality, font size, resolution, light conditions, hue and noise. Even on high quality receipt, OCR may confuse similar looking characters such as O and O or commas or and decimal point. Therefore, pre-processing and post-processing are important for improving accuracy. Now we will be installing the Gemini SDK. For that, step 1 would be install the Gemini SDK. One piece of code you have to write: pip install Google GenAI. Second is import the libraries. From Google, import GenAI. Configure your API key. Now, how to get your Google API key? You will be going to this website, aistudio.google.com. Here you will go to API key and you will click on create API key. When you will go and click on create API key, you will click here, a API will be created. You will be just have to copy it from here. When you will copy it from here, you have to go this to the secrets, add new secret. You have to type Google in capital letter, Google underscore API underscore key. What you have to write, I will and you have to paste what you have copied from there to here. Okay, in that value one. So then you can configure your API key. So step 3 is, I have done already because I don't want to expose the API key. So that's why I've done it already, but you have to do it and never show this API key to anyone. So because someone can misuse it. So you have to type this over here in name and value which you have copied from there, and you have to give to access to notebook, and then you can see that it is working fine. And if you want to check it, you can just write this piece of code, and here we are using model Gemini 2.5 flash, and if it's printing hello, it is working fine. Now we will connect our OCR with Gemini. How? You will simply write this prompt and if you just check it, your JSON is being printed. So that was our objective, to print that this JSON. So we can do many more things. We can deploy it and we can like have a front end back end. If you comment it out, I will just make more further, but till now we have completed this project. So from the images we have retained the text, and with the help of use of Gemini we have converted it into JSON format. And I think like this is till here we have done it. We have using the model Gemini 2.5 flash. This from the interview point of view, this is a very this question, and this is the first generative AI project which I am building over here. So I think that this would be very helpful for you like to do further the things and understand it. And if you have any doubt, you can just comment it out, or you can just mail me. In every description I give my mail, so you can personally mail me. So okay, so this was from my side, and I hope you understand it. If not, you can just rewatch this video. You will get the things, how the things are working. And I know it, for in the starting it is a bit difficult for you to understand, but once you will start doing and practicing it, it will become fine. So thank you guys. If you like the video, you can just if you like the video and how I've explained it, you can just like the video, subscribe to my channel, and comment it out, and share with your friends so that they can also build some projects on AI and all. Okay, thank you everyone.